So, Thomas, what was your first computer?
So my first computer was actually bought by my dad, and it was a Pentium, small Pentium. And my first programming language on the computer was, by the way, JavaScript. So the first programming language I was growing up with was JavaScript.
And you started immediately hacking, or you played some games first?
I played games before I was doing the hacking on JavaScript. But then we were like the first type of programs I made was this type of like websites where you can hover with your mouse over a picture and it would replace the picture or do some animation. And this is what attracted me initially to programming.
Okay. But what's interests me, the process, how you started with programming. So your first computer was still Intel. And what was the very first thing you did on the computer?
I think actually one of the very first things I did on a computer was to, you remember this Turbo Pascal?
Yes.
It's this, and Turbo Pascal had like these games, Snake, and also the gorilla game, where the two gorillas are like throwing stuff at each other.
Mm-hmm.
And these were the first two like games I was playing on that computer. And but I never then I tried a little bit of Turbo Pascal programming to kind of also create a game, but I never got very far with the Turbo Pascal thing, and then rather went to the browser.
Yeah, but how you got the idea at all that you can actually start programming with the computer? So is your dad a programmer, or what's the story?
My dad and mom are both mathematics and physics teachers.
Ah, okay.
And so they actually were like pioneering a little bit in the sense that back then there was no such thing as a teacher of computer science in the Austrian schools. So they were actually also self-taught and then teaching to like about the 16, 17-year-old at school, some programming, and they were certainly helping me with this education to be a programmer, and bought me also some books on JavaScript, for example, that got me into this. So you can say it started with my parents being mathematics and physics teachers.
Yeah, but it's like they gently, forced you to program, or was really your idea, to start programming?
No, that was my idea, but it was also partly because I have like an older sister, and the older sister is like 5-6 years older, and as a child I always was trying to do whatever she was doing as early as possible. And she was starting to study some type of web design at the university, and so that was another reason why I got like inspired of like, I want to do what my older sister is doing.
Ah, cool. So I suppose your older sister did some great design with the website, so you saw that and try to understand what's going on, right?
Yes, correct. And then from that I got into this JavaScript programming where like you need to do some animation on when the mouse moves, etc.
Very cool. So your first programming language was actually JavaScript, and probably what you did is view sourced on the NetBeans web browser, and then start hacking JavaScript, right?
Correct. Yes.
And
yes, and that was still back in the days where you needed to have two versions of your JavaScript, one for Netscape and one for Internet Explorer.
Oh, so it's that early. So, by the way, the Intel Pentium you got, which CPU was it? You remember that? It was like Pentium 1, 2, or whatever was it?
I don't know. I think it was probably, I think it was maybe generation 3 already.
Okay. So, actually, it was like a beefy machine what you got back then.
Yeah, absolutely.
You're perfect. So, and then what was your first, serious, more interesting project you did with programming?
One of the first projects I did was I was doing then like a website for my classmates.
Okay.
Where like it's actually from the idea perspective a little bit like these platforms like Facebook or StudiVZ.
Yeah, this is what I wanted to say.
Like where classmates would upload pictures and they would upload websites. They would upload like their homework And there was also a chat room, and the technology behind it was PHP. So I had server-side PHP and client-side JavaScript.
Okay.
But I was doing PHP, but I didn't know anything about databases or anything like that. So that's when I was storing everything in text files.
Which is actually a good idea,
database,
right?
Yeah, it worked fine for the number of users I had. Maybe it wouldn't scale to tens of thousands or users, but it worked very well. And so my database was text files, server-side PHP, and client-side JavaScript.
And how well
also a little bit of
how well did it work? So it's like your mates really liked the platform, or was you were alone on it?
No, they did like the platform. Yeah, absolutely. Like my schoolmates liked the platform. They uploaded their stuff there, and with that, I was then submitting to a competition in Austria, and I won like the competition in Austria nationwide with this type of project. This was like an informatics competition.
Cool. And so you had IP address or DNS, so how you deal with that? So how you?
No, sorry. So no. The server space was with some some educational institution had a server space for me, but it was not in my school directly, but yeah, an educational institution in my country had like these server spaces, free server spaces for kids.
And what was the name of the platform?
So this was just it didn't have it was just like based on the name of the name of my class. So it was just called 4B, and it was like the website for my class, right? And yeah, back then I didn't have kind of the intention to move it to like a larger type of platform. But then my second project there was a platform that was called GameScript.
How old were you back then?
I was back then 13 years old.
Oh, that's amazing.
I started relatively early there, but
okay. And then what?
And then the second platform I built was called GameScript, which was because I thought I want my colleagues also to learn programming. And so I built a mini language that would be a subset of JavaScript, and that could be used to build small games, and specifically also used to build the AI for some of the games. So the platform would be there would be a game, and then you could use GameScript to program the bot of that game.
Okay.
And this was another one and this was kind of my first programming language, you can say, that I was building.
Yeah. So what's interesting? How you got the idea that it actually can create your own programming language? So were you inspired by someone, or did you read some books, or because this is not really unusual? I mean,
I don't know. I just felt like I don't remember, but it was more like, well, it seems to be the case that JavaScript is kind of complex, and I wanted something simpler, and that's when I was doing this this subset of a programming language. But I always was fascinated with programming languages, and started building first these interpreters, and then later also compilers for it relatively early.
And have you started to program your language? So you mean it was probably interpreted or compiled? So you used the custom tooling?
It was only interpreted. So it was just an interpretation on the server side of this language, because I didn't know anything about machine code or compilation or anything like that. So that was my only way to do it. And only later on, when I did my second language, I was like, oh, I really want it to be compiled, because compiled sounds so much better, because it's so much faster. So that was when I did my first compiled language. It was maybe 1 or 2 years later. But the way I did the compilation was very awkward. It was like basically a template compiler, and I didn't have any assembler, so I was just putting out x86 instructions into a buffer in C++, and then converting that buffer into a function pointer and calling it.
So, what was the name of the first language? How you named that?
The first language was GameScript, right? It was
GameScript,
the
okay.
subset language, yeah.
And how it worked?
Yeah.
So how the interpreter worked? So you just read your own commands, and then what
it
you
was
did?
It was an EST interpreter, right? It would first parse this into an abstract syntax tree, and then it would interpret that abstract syntax tree. And the parser was, of course, written by hand because I didn't know anything about parser generators or all this technology. I didn't know about anything like that. So I was just writing by hand something that would parse the language.
And you knew about ESTs back then, or you reinvented it, without knowing it?
I don't think I knew about ESTs. It was I think just the most natural way I would represent this.
Okay, cool.
This program.
So, and your second language, what was the name of the second language?
So this second language that I talked about, I made for a small company that did like kind of something similar to, you could say, smart home, where you can program your solar installation or something like that. So I didn't ever publish that language under a specific name. It was just the internal language that was used on this devices that would then display the home for you.
And
so you could use it to script your display of this smart home system.
And why there was a need for a language? So why you couldn't use C or assembler or whatever?
There was not a real need for that. Obviously, I kind of invented that need because I wanted to have fun, like programming a language.
Okay. That's cool. Okay.
I would say in hindsight, and I had like a company paying me for that, so that's great.
Okay, cool. So was it after the university, or what was it?
This was I was about 16, so I was still at school.
So how you got the job? So how you got the job? To convince a company, to pay you to invent a language. So I mean, this is an interesting story, right?
Well, the language was just a small part of the overall project, right? So I did a lot of programming for this company. The thing that I did specifically is I built like this little it's more like a visual programming language, you could say.
Okay.
As well, where you would like put elements on the screen and connect them based on your solar installation or based on the devices you have in your system. And so I was engaged by the company based on a recommendation of a school friend, and then only later on, like this language was just a small part of this programming engagement.
Okay.
But in this programming engagement, this is very interesting because I was basically like one guy for like building a whole system with graphical user interface and other components. It was built based on the Qt framework.
Okay.
Which is this C++ framework, which is still pretty active, I think. And nowadays, I think it's owned by Nokia.
Yeah.
And this was a very nice, I think it's a very awesome graphical user interface framework, actually.
Okay.
And this was all C++ programming.
And in what was your regular school? So was it like a kind of high school or where you went to the school?
I was just in a regular gymnasium in Austria.
Okay.
So this is, you have like actually not, I wasn't very, like I had like, languages and everything, like, I was learning French and so it wasn't very focused on computer science in any way. And specifically the computer science education at the school wasn't that great. So I was doing all of this more at home.
Yeah, the same is in Germany. So the gymnasium is also in Germany, and this is actually, the school is pretty hard. So it's like, but there's nothing to do with computer science usually.
Yeah, exactly. Yeah, and so one of the things I did is because I was like a decent student, so I was overtaking one class. So I was not I was jumping over one class when I was 15.
Mm-hmm.
So I went only then 7 years to the gymnasium instead of 8.
That's amazing. So what's interesting me, how you did it, because I thought about something like this a lot. So I'm like, if someone overtakes a class, it's like you learned a lot, or so I mean, because several things, you have to learn. It is impossible now just to know out of cuff, I don't know, some history or whatever. So you have to read something. So you learned a lot, you enjoyed learning. So how much time did you spend with the school?
Yeah, so I did not spend so much time with the school. School was something for me that I wanted to basically get over with quickly.
Yeah.
And how much time I spent depended a little bit on the type of subject, right?
Yeah.
So in the maths subject, obviously it was very easy for me because I just got a lot of and a lot of education, frankly, also just because my parents are the maths and physics teachers, so they could help me a lot while I was at home. The most difficult parts for me when jumping over the class was something like French.
Yeah.
Because a full year of French was pretty hard to cover. But I mean, we have like 2 months of vacation for students and for pupils, and I could just catch up there a little bit, and ultimately it took me after I jumped over one class, it took me about I think about 6 months in the new class to adjust to the new level and stuff. And of course there was also the social aspects of it. But I was lucky that the new classmates and so on were all pretty nice to me and were not seeing me as like but were seeing me positively.
Okay. So and why you did it? Because to spend the whole vacations to learn French. So I would prefer to hack with computers and just stay 1 year longer in the class, and have easy living and hack all the time. So what was your thinking back then?
Oh, yeah, the thinking was just to get over with school so I can start like studying computer science, right?
Okay.
So I wanted to get as fast as possible to university. And there's another thing I did back then is I started to actually go to university like next to school. There was like this program where you could have a couple courses at university while you're still at school. And so I was 15 back then when this program was starting. And so that was when I was, I think, so when I was 16, I was starting to go to a few courses at the Linz University. And my first course at university was, of course, the compiler construction. And it was the advanced course in compiler construction.
Okay.
Because then I was like, oh, I really want to know how this works for real. And I was lacking so much basic knowledge on my first few compiler-based projects.
Okay.
So I was going to this class of my professor, Peter Messenberg.
Okay, so now I understood a little bit. So what you did is you were very fascinated with computers and you wanted really to learn programming or compilers. In one point of time, you recognize the only thing to do it is at university. So you started to learn as quickly as possible to skip as much stuff which is irrelevant to you in gymnasium just to get over it, and then start with the real fun, which was compiler building, right?
Yes.
Okay, so now I got you. So you were not kind of a prodigy child, but you were also very focused on what you want to achieve, and you just learned a lot, whatever was necessary to accomplish that. So, right?
Yes, absolutely. And I was always fascinated with numbers and with computers and with programming, and then later with programming languages, because I think it's for me, it was always the most interesting part of computer science. It's not so sexy anymore. Nowadays, people are more like, well, you need to do machine learning or something like that. But for me, always compiler construction and programming languages was the most interesting part of computer science.
And at the gymnasium, do you have to apply to to take over the class, or it just happens? So if you have very good, marks, where they come to you and say, okay, now you can skip the class, or how it works, I'm just interested.
No, you need to apply, and
okay.
there is I also needed to go to some psychologists to check my capabilities, etc.
Mhm.
And but I was lucky that there was that the leadership of the school was friendly to me, so they allowed me to do it.
Mhm.
And so that's how I could do it. And there were like I always felt there was like two type of teachers or other people around me. Like one type were like very supportive, and they were like, yeah, this is great, and we will support you in your desire to do this faster here. And there was also the other fraction that was always like, no, we think this is bad. You're like you're stealing the child like 1 year of his childhood, etc., etc. So it was very interesting to see this somewhat of a divide of people looking at this jumping over one class.
Yeah, and I think it really depends on whether it was your decision or not your decision, right? It's your decision to learn more afterwards. You can just do it, and then you can just have 1 year vacation. So instead of learning, something boring at school, I would just skip over whatever I can and then have decent life afterwards. So you can always adjust, to this. So this is not like the year is lost. It's more like if you are smart, you can right now you can have 1 year vacations, and you will be the same.
Exactly.
Yeah. So this is not like lost year.
Yeah, exactly. It's not a lost year. Absolutely, yes. And I felt the same way, and still think it was absolutely the right move to do, because later on I could use that year with much better knowledge, and so I could start the Graphian project earlier, basically.
Okay. And so you were at university. So what interests me now, so in parallel to the school, you went to the university, you could just attend the lessons. Is this allowed for everyone, or you had some special, approval from someone? So you could just join the university courses?
Yeah. So this was allowed for, I think this is allowed for everyone. But it's you need to I could not complete like I could. So I was a special student. There's a special thing for that, meaning I could not write a master thesis, or I could not write a bachelor thesis. I could only do individual courses.
Okay.
And then later on, I needed to transform those individual courses to the actual study that I would do.
Okay.
And yeah, but for me, this was really awesome, because I could suddenly get all the missing knowledge that just because my parents, at some point, couldn't help me anymore in terms of the computer science education. And,
yeah,
and then
after 2 weeks, I think, right? So after 2 weeks in your university was, I think, game over, right?
Yeah. So that's when it was very important to have sort of also then real university professors like Peter Messenberg, that was later then also my PhD father, help with the actual knowledge.
Okay, cool. So interesting. So in during the gymnasium, so we are talking now. Which class did you took over? So when was it? Which class was it?
It was the fifth.
Oh,
so which means in a regular system, it's would be the 9th, right? Because we have 4 years primary school,
okay,
and then 8 years gymnasium, and the 5th one is the one scheme.
Okay, so then and during gymnasium, you already built some compilers. So what was your third? So the second one was for the solar panel company.
Yeah,
right?
The second one was for yes. And the other thing I did during university was that I did a lot of programming competitions.
Okay.
So
how well did you?
Programming competitions. So my best result was the gold medal and 3rd place worldwide in Wisconsin, USA.
This is no kidding. So and was it is this for children, or for youth, or is it over?
So this was the International Olympiad in Informatics, right?
Okay.
So these are the Olympiads that are done for various subjects, and one is in informatics.
Okay.
And this is for people from 15 to 19 years.
Okay.
Approximately. So it's basically in the just before university, you would do these programming competitions.
Yeah, incredible.
And there is like this like every country sends the 4 best people to this worldwide contest.
Okay.
And I was lucky in my first attempt in Austria. I was kind of one of the 4 that could go to South Korea.
Okay.
To the International Olympiad. But there I was too young. I didn't do very well. But then on my second attempt in USA, in Wisconsin, I was very lucky and did very well there. And it gave me a lot of motivation to pursue this computer science and programming career further.
Okay.
And one fun fact about these programming competitions is that my main colleagues there, basically the 4 best people from Austria that went to this programming competition in South Korea, which was Lukas Stadler, Christian Wirth, and Roland Schatz, were the other 3. Back then they were about they are about 3-4 years older than me. But so they are all of these are now in the Gravium team.
This is actually perfect for you, right? Because you can remember the old times. So it's like, right?
Absolutely. And so this was very great to have such a good teammates also back then. And I can still have those teammates now on the Gravium team when we do like here the real VM and compiler work.
Very cool. And so this was. First question is about the competition. What you had to do at the competition? So was it like a task and you have to solve it, or what is it? Such a competition? What you can imagine? So
so the competition is it's on 2 days, and on each day it's 5 hours.
Okay.
And in those 5 hours you get 3 tasks, and the tasks are typically each of them of some algorithmic nature.
Okay.
Could be so the underlying algorithms that you would need to know to solve this task are, graph traversals, network flow calculations, distance, smallest distance, minimum spanning tree, and so on. But the tasks would typically always require a combination of these algorithms to be applied together. And the task is done in a way where the input is a text file, and you pass the input, and the output is also a text file.
Okay.
And after these 5 hours, you submit the programs that you did, and then they are graded. But you never get sort of an intermediate result. So it's basically one shot. It's not trial and error for you. There's only one shot where you can submit your program, and then it either works or it doesn't. And then it's graded based on the algorithmic complexity with which you solved it, and on the correctness. So it's given typically about 10 different inputs, and for each input you either score the point or you don't score it.
Okay. And the easier the better, right? So the easier or the more simple the solution, the higher graded, or the more complex you solve the problem, the higher it is graded.
The inputs are typically, for example, you have a graph problem, right? And then the first input is with 10 nodes, the next one is with 100 nodes, the next one is 1,000 nodes, right?
Okay.
So the inputs get more and more difficult.
Okay.
And some of the more difficult inputs your program will only be able to solve if you choose the absolute best algorithm possible.
Okay.
But some of the simpler inputs you will also be able to solve if your program is more primitive. So if your program is more brute force.
Okay.
And typically those algorithms have some brute force solution that's relatively straightforward to program. But then you have some sophisticated solution that has a faster runtime. And then you get more points.
And you could choose any programming language, or you create your own language for that, or what was the idea?
So there were two languages. Actually, there were 3 languages as choices. One was Pascal, the other C, and the other Java. But typically, most of the participants would program in either Pascal or C.
Okay.
And I would program in C and in VI. So I would be And it was a very funny type of programming style as well, where like you program in pure C, and if you do a linked list or something like this, you do it as an array with indices into the next elements and stuff like that. So you try to avoid any dynamic allocation because you want to make your program very easy to debug for you. And you would train yourself to be very fast in programming the standard algorithms up and down. And so in my first attempt to program to participate in these competitions, I wasn't so good because I kind of made small mistakes in my program, and that cost me a lot of points later on. And so that was when I was trying to figure out how do I do this more efficiently. And I started in my training sessions, I started to time my progress, kind of like how long does it take me to read the program statement, how long does it take me to program the solution, and then how long does it take me to debug the solution. And the result, of course, was that it takes quite some time to read the problem and to kind of understand it. But then programming the solution, once you kind of know approximately what you're doing, is super fast. But then if you make any type of mistake or something like this, then debugging can like destroy your whole result and be really the deciding factor, right?
Yeah.
And based on this, I was then in my second attempt there, that was much more successful. I was then trying to be trying to not only program the solution, but also program a test generator and program a simpler solution that would verify my complex solution. So I would do a lot more programming, but then but this was the fast part basically, and this enabled me to submit something that wasn't having any of these like small mistakes. So this is kind of like a major takeaway for me from this programming competition was like programming stuff is actually super fast, but debugging the things, etc., or like finding out where the error is once you have one is the really slow part.
Yeah. And what interests me, so you had to train a lot, I think, right, for this competition. So you did lots of work before. I
did train for this competition. Yes, I did train for usually about 6 months before. I would train for like the next 6 months or so.
And how long a day? I would say 1 hour, 2 hours. So how much did you spend training just for that?
I would say I probably trained maybe 2-3 hours a day, I think, but more in bursts, right? It was more like, one afternoon or something, I would just train there, and then but I think probably 2-3 hours a day for like 6 months, I think would be approximately how much I would train. And there's like this nice website. I think it still exists. Let me actually check that. Yeah, there's this website called USACO, which is a website from the U.S. Computing Association, and they have a USACO training website where you can train these programs, and this was very useful for me because they had all these and it was like the whole website was a little bit like a computer game where you kind of get scores and you unlock the next level, etc. So for me, then training here was like almost like playing a computer game where you in order to unlock the next level, you solve the next problem, right?
Yeah, but why I'm asking this question, because nothing comes for free, right? So if you do whatever for 2-3 hours a day, 6 months long, you could actually achieve remarkable things. So you could run a marathon, you can do whatever you like if you have this dedication, right? So it's not like if people achieve something or win something, it always looks like, oh, it is a prodigy here, did something, without work. But it's always hard work and motivation behind.
Absolutely, yes, absolutely. And the training is absolutely necessary, because without that, you will not have much of a chance there. And it was for us.
Wait a second. Do you think this is possible? that someone wins such a competition without any training?
No, I don't think so. No.
Yeah, this is also my.
You have to have the basic algorithms and need to know those and you are like the thing on the competition is like we were from Austria, so we were like from this small country where like where it's relatively simple, let's say, to qualify for the worldwide stage. But then on that competition, there were always like, you know, the 4 best from Russia, the 4 best from China, the 4 best from USA. And we were always super afraid of those guys because they came out of a much, much larger selection. And it was very nice for me that in this, at least in this one instance, in this competition in the USA, when I got the 3rd place worldwide overall, I could beat all these guys that would like be trained super, super hard and that would come out of a very large selection of people. But for a very good result on the competition, you also need to have some luck, etc., because it just needs to be the right type of problem that you are lucky enough to solve that fast, right? I would say that the top, there's about 300 people participating in that worldwide on this worldwide stage, and I would say the top 50 are all like super good programmers.
Yeah,
and we're actually interested to hire more of such programmers into the team that have some programming competition experience.
Okay.
And it's
question
it's
about
not everything.
About the competition, or about you particularly. So you were really interested in compiler. So you attended the university sessions, and then seems like the programming competition do not match your strategy anymore from my perspective, because you had to know algorithms which to my knowledge are not really necessary to create decent compilers. So why you were motivated to participate in such competitions, or what was the idea or your motivation back then?
Well, I think one thing is I'm generally a very competitive personality.
Okay.
So I like competition and competition, like positive competition with others is always a motivating factor for me.
Okay.
But I would argue that this type of competitions are actually very good preparation for compiler construction.
Okay.
Because a lot of the algorithms required, like not all of them, but like a large majority are based on some graph algorithms.
Yeah, it's true.
So graph traversals, etc. And in compiler construction, typically there's also a lot of algorithms that are graph based. And for me, like graph data structures, graph algorithms, anything to do with graph is very natural for me. It's something I like very much.
Okay.
And,
so lots of the algorithms you already knew because you were interested in compilers, or at least you had an instinct what could work and what not, right?
Yeah, but the algorithms themselves, I wouldn't like. I was interested in compilers, but the way I did compilers was, even without graphs back then, right?
Okay.
I was just outputting these templates based on the instructions, of the language. But the algorithms, I had like algorithm books. There is this standard books on these algorithms, and I was reading those. I was learning those from books as well.
What books? I have one from Edison Wesley. Is this also a standard? Like the algorithm book, like 1,000 pages, all the algorithms in C, something like this, or what are these standard books? Yeah. Okay.
Yes. I think it's actually that one. It's actually that one that I had. Yeah.
Okay. Cool. So, perfect. So, you was it still at your gymnasium time, or was it university time, your programming competitions?
This was at gymnasium time, but then later at university I also did programming competition, but these are different ones. This is the ACM contests.
Okay.
So the ACM contests are for students.
Okay.
And this I did, of course, with my former mates from the IOI competitions.
Of course, yeah.
With Christian Wirth and Roland Schatz again. And so these have also regional competitions and then the worldwide competition. And there we made it as a team to the worldwide competition in Japan, where like the best universities are competing. And they are very similar in nature. In terms of the problems, I would say similar. But here, it's even more interesting in the sense that it's a team competition where you have 3 people and you have 1 computer.
Okay.
So and one keyboard.
Okay.
So you need to solve as many problems as possible, as fast as possible.
Mm-hmm.
And you get like an insane amount of problems, like I think 12 problems for like 5 hours.
Mm-hmm.
So nobody can solve all of them typically, but you try to just solve as many as possible.
Mm-hmm.
And this is interesting because in this competition, because you have to share one computer, you have to also train a bit of teamwork, like pair programming, and also you need to kind of know each other a little bit of who can solve which problem the fastest.
Okay.
Typically, everybody has like a certain speciality of problems that are more suitable to him.
Mm-hmm.
And so I did some programming competitions then also later on. But yeah, it was fun to do those then also at the student level.
About the compilers, what was your ultimate goal? So you tried to build, I don't know, a compiler which is like, the impossible compiler, or you were motivated by something more? But because just compilers, I mean, why you did all this stuff? So were your motivations to build something like, GraalVM from the beginning, or what was it? What was your main motivation? I don't think you just wanted to build compilers just to build a compiler.
I don't know. I think my main motivation here is just to advance, like to advance the way people would program. I mean, compilers is kind of the thing between people and the computer.
Mm-hmm.
So I feel like by having a better technology there, we can enable people to like program more productively, for example, or run the programs more efficiently. So we enable people to be more productive with the machine, right?
Mm-hmm.
I think that's the underlying motivation to a lot of these things.
Mm-hmm.
And I think in the compiler construction field, we are still only at the very beginning of what would be possible. And I think ultimately we will, because I think there's still a lot of things, even nowadays, that are done by humans in that process of programming that should be actually done by machines. And because like the human in the end should be more just the creative input to what should be achieved.
Mm-hmm.
And anything anything else should be done more by the machine itself.
Mm-hmm.
And by having better compilers, we can enable the human to kind of express the intent in a more high level, mm-hmm. or just express the intent more efficiently, faster. Mm-hmm. And then the compiler and the runtime in between makes sure that this intent is most efficiently fulfilled than by the machine. So
you just basically wanted to talk to computers faster, right? This was motivation. So I just wanted to express as efficiently as possible my intent, and then computer should do whatever the computer has to do, and it's over. This was your fascination.
Yes.
Cool.
Yes. That is my fascination with the topic. Yes, it's still nowadays. Actually, this is the main part of what I think is interesting in that field.
So during gymnasium, so you learned JavaScript first, then Turbo Pascal, and then you mentioned C. How you learned C? Just by accident or?
C, yes.
Okay. Yeah. How? So
you found... It was C. I learned. Yeah. So after JavaScript, I learned C, and I learned C mainly for the programming competitions. Because in the programming competition, we couldn't use JavaScript. It was not an option, and it would also be probably too slow back then to execute. Mm-hmm. And that is when I learned C.
Okay. And how fast you learned C? Took you, I don't know, months?
I don't think it took me long. Yeah, because I already knew JavaScript, so I had all the operators, etc. I all knew them, and C is pretty simple. Yeah. And also the type of C I was doing, it wasn't even using pointers much. It was everything was statically allocated, and so it's really a small step from JavaScript to C.
Yeah, and you got you mentioned pointers. So at one point of time you saw the pointers. So you got them immediately, or it took you a little bit to figure out what they are actually?
I think I as a JavaScript programmer, I was familiar with this references, or that it would pass by reference and not pass by value certain objects. So in that sense, that pointers would actually be more natural. But we wouldn't use pointers here at the beginning. Later on, when I was using Qt at this company, then I needed to learn C++, which was not so easy, because C++ adds a lot of additional constructs. And the Qt framework also uses a lot of tricks to do some automatic memory management with C++, etc. So I would say C++ was rather difficult, but C is really straightforward.
So what came after C++?
After that, I did learn Java.
Okay.
Because at university they were doing Java in the courses, and and that was my first Java programs.
And you like Java from the beginning, or what was your relation to Java?
Yeah, I like Java, but I was at the beginning. I was having difficulty grasping this constructor concept, and I wasn't sure of what this is about, and so it wasn't easy for me initially to develop the object-oriented thinking of interfaces and constructors. I mean, coming here from a C background or also JavaScript background, none of this was kind of necessary, and it didn't feel initially very natural to me to have these concepts around.
Okay. And which Java was it? JDK 1.1, 1.2?
I think that was my first Java programs were written in 2001.
Okay.
So that's already JDK 1.4 almost, I think.
Yeah. Okay. So it was advanced. So already with Hotspot, I think, because Hotspot was introduced in JDK 1.3, right?
Yeah.
Okay.
Yeah. And I also remember doing some applets, actually, which was another reason to use Java, because applets were possible.
Was it like decent applet with lots of animation, or what you did with the applet, or just, AWC stuff?
Yes, with animation, yes.
Okay.
Yes, no, with animation.
Okay, cool. And what was it?
Actually, this GameScript that I was talking about was written as applets in the browser.
Hey, cool. From the beginning?
Yes.
Ah, okay, cool. Interesting. So I think you wrote the first interpreter which ran as an applet, right?
Yes, correct. That is
one of the first.
Yes. And and it would interpret the JavaScript subset that was typed into that applet. Yes.
Okay. But it didn't communicate it with the DOM of the browser. It was just like self-contained app, right?
Yeah, correct.
Okay, cool. Yeah, very cool. So, and at the university, you also overtook some classes, or you just, enjoyed the university life?
I did study faster than usual. Yes, I did my master in 3 years instead of 5 years.
Okay.
I did that by basically subscribing. The nice thing in university is you can subscribe to many classes at the same time, and you just need to do the exam in the end, and then you're good. And so I more or less double subscribed to a lot of classes. Yeah.
And your strategy was better at university. What I did is I worked full time and did university at the same time, and this was terrible. So after university, I was really happy that the university is over. But or university, I didn't study at university rather than like applied science university in Germany. And so I did all the classes, regular classes, and try to learn as little as possible. And then work as much as possible. And this was, I think, a better idea would be to try to study as fast as possible and then have a nicer life afterwards.
Right. Yeah. No, I agree. Yeah, and that's what I did. Yeah, I wasn't working or almost not working at all during university.
Yeah.
And just tried to do one course after the other. And I didn't go to all of the classes, and I didn't go to the class itself. But this was sometimes challenging because you're missing some context.
Yeah.
So I often spend time trying to figure out what is meant, what's the context for certain exercises.
Yeah, and
overall, this was nice because
how you like the university? Because in my case, what I found out in university is not everything what we learn makes sense. So for me, it was really hard in one point of time, to learn also things which are probably not that relevant to me. So what was your motivation at university? You just, this interests me right now. So were you still delighted from the university, or what was your, take then?
Yeah, I mean, I think it was similar in the sense there were some courses that I think were very interesting for me.
Yeah.
And I enjoyed them, but there were quite some courses that I was not interested in. I was just trying to get over with as fast as possible.
Yeah, okay.
So I didn't enjoy things like operating systems or hardware. I was specifically not interested in anything related to hardware.
Okay.
And had a very tough time, trying to follow these things.
And you still got good marks, or were they just good enough?
No, I still got good marks. I actually got this where you have the best mark in every subject, but I didn't enjoy it much. I was just trying to get it over with.
That's interests me, because we had some really strange professors in the university, and there was one a Mission Impossible guy. So there was I think there were just 3 people who passed and everyone else not. And this was numerical mathematics, but in strange programming language, old ones. And I just wanted, to pass the exam. And in one point of time, I got the Mark 3, which means it's okay. And but I wondered, is it actually possible to have an 1, also very good in this particular course? But I don't think so. So, and you achieved everyone, the best marks. So, I mean, how is it possible? So there are, some courses where there is a Mission Impossible to have, the mark very good. So this interests me. What you did?
The marks, right? So when I say I achieved the best mark, it was always across a certain set of courses. So the way this is calculated is that 3 courses are kind of put together.
Okay.
So you don't need the best mark in every individual one. You can have a B in one if you have A in the others.
Okay.
And it was very narrow for me as well. But this was something I wanted to do, because if you achieve this, then the president of Austria is attending your PhD ceremony.
Okay, cool.
So that was a goal that was kind of interesting to achieve.
And you just wanted to disturb his vacations, right? So I will be the first, so he will come, to me and listen to my stuff, right?
That's right, and then you're allowed to say something, and it was fun.
But I get you. So I think you are competitive guys who say, okay, either I waste the time, or I learn a little bit more, and I'm the best, and why not? It's more fun.
Right, yeah, but I tried to get it over with still quickly, and the nice thing was that for my bachelor thesis, I was then already working at this institute of Professor Messenbach on my first project on the hotspot virtual machine.
Hi, Adam is here. We forgot the time and recorded a way too long episode. So I will split the episode into halves. So in the second half, we will cover GraalVM in more detail. Thank you for listening, and bye.